Today's lesson is on linear modelling. So linear modelling is a way that we use a linear function to describe a practical situation. So if we think of our gradient intercept form, so y equals mx plus c, we can model different practical situations. So our example here is we have a catering company. Now that catering company is charging an amount of $100 plus $25 per guest. So using this information, we can actually create a linear relationship between these two variables. So we can say the total cost, or C, is going to equal $100 plus a $25 per guest. So C is the cost of the event, N is the number of guests. So if we look over here, we can see this is the graph of that. So using the graph, we can see how much it's going to cost per the number of people. So if we had 20 people, for example, if we go up to here and then across to here, that tells us that that is going to cost us $500 in terms of our catering cost. So when we're thinking about our dependent and our independent variables, the y in our relationship is dependent on the x. So we call y the dependent and x the independent. So when a function is graphed, the independent variable is generally on the horizontal and the dependent variable is on the vertical axis. So if we go through some examples to try and help you with this, our first example here is we've got water is pumped into a partially full tank. The graph gives the volume of the water V in litres after t minutes. How much water is in the tank at the start? So this is telling us where does this line cross on our vertical axis. So that crosses at 400. So we're going to have 400 litres in our tank to begin with. To find out how much water is in the tank after 10 minutes, we go to our 10, we draw a line straight up and then straight across. So that's telling us that in the tank after 10 minutes, we'll have 1,400 litres of water. If the tank holds 1,600 litres, how long does it take to fill? So to figure that one out, we need to go to this axis, find our 1,600, go straight across to our line, and then straight down to the 12. So it's going to take 12 minutes to completely fill that tank. So if we wanted to find the equation of the line in terms of V and T, think of it as our y equals mx plus c. So our constant, our c, is where it's crossing that line there. So that's at 400. For our gradient m, if we pick our first, the one that we did up here, so our 10 and our 1400. So what that's saying is we've gone from 0 across to 10. So our run will be 10, and we've gone from 400 up to 1400. So that's a difference of 1,000. So we can say our gradient is 100. So for every minute, there is 100 litres going into the tank. So we can make our equation V equals 100T plus 400. So we can now use this equation to calculate the volume of water in the tank after any number of minutes, or we can go back the other way. So if we wanted to use the equation to calculate the volume after 7 minutes, we do V equals 100 times 7. So our T is now equal to 7 plus 400. So that's going to equal 1,100 litres. How many litres are pumped into the tank each minute? We worked that out back in part D. So 100 litres per minute is going into the tank. A second example here, a phone company charges a monthly service fee plus the cost of calls. The graph gives the total monthly charge, C, in dollars for making N calls. This includes the service fee. So how much is the monthly service fee? Again, we need to look at where it's crossing our vertical axis. So our monthly service fee would be $15. How much does the company charge if you make 20 calls per month? So to find that out, we need to go across to our N equals 20. We go up to our line and we go across. So we're looking at approximately $25 for a month where you've made 20 calls. How many calls are made if the total monthly charge is $30? So to work that one out, we need to look at our vertical axis at the 30. We need to go across and we need to go down. So we're looking at approximately, so that's what that little squiggly line is, 30 calls. To find the equation of the line in terms of total monthly charges versus the number of calls, we can use any of the points that we've just found. So I'm going to use our initial point. Our charge equals 15. That's when n equals 0. So I'm going to use that point there. So that tells us, again, so y equals mx plus c is the form of this type of equation. So we're looking for c equals, so we're going to have 15 plus, and we need to work out what our number of calls is. So to work that out, we need to determine our gradient. So for our second point, if we look at this point here, we've made 30 calls. So our run, when we look at our gradient, our run across is 30 because we've gone from 0 to 30. And we've gone from 15 up to 30 here. So that's a difference of 15. So our gradient is a half. So it's 15 plus half the number of calls. So for each call that you make, you're only being charged 50 cents. So for each call you make, you're only being charged 50 cents. So this would be the formula that we would use to determine the points on that graph. Conversion graphs are another form of linear relationship. So this is something that we would use to convert between different units, so metric and imperial, or between foreign currencies. So what I've given you here in this example is I've shown you a conversion graph used to convert Australian dollars to Chinese yen. Okay, if we're going to convert 80 Australian dollars to yen, we're going here at the 80, we're going up and across. We will get 400 yen. If we are trying to convert 50, so 50 would be between the 40 and the 60. That would give us 250 yen. Now, if we're going the other way, so this one here, we want to convert the yen to Australian. So we find our 100 on the vertical axis, we go across and we go down. So that would be 20 Australian dollars. And if we're looking at 350, that's going to come halfway between our 400 and our 300. So we'd be looking at 70. So what is the gradient of the conversion graph? So I'm going to pick these points here just because they're nice and easy. So if we're looking at y equals mx plus c, again, as our formula, our c is going to equal 0 because we're crossing here at the origin. And my gradient is going to be, we've gone across to 20, so my run is 20, and my rise is 100. So it's going to go across 5. So for every $1 I have of Australian, I have 5 yen. Yen equals 5A. So our Australian dollar is the A, our Y is our yen. Okay, for question 2 here. Thomas converted 100 Australian dollars to British pounds. Draw a conversion graph with Australian dollars on the horizontal and British pounds on the vertical. So this is our horizontal, this is our vertical. So we want to convert 100 Australian dollars. So I'm going to go up in lots of 20. So 20, 40, 60, 80, 100, 120. Then up our horizontal, I'm going to go up in 10. So 10, 20, 70, etc., etc. So our first point that we know is when we have 100 Australian dollars, we're going to have 50 British pounds. So that's our point there. So then we can just get our ruler and draw our straight line. And that would be our conversion line. So now if we wanted to find out how many British pounds is 40 Australian dollars, we'd go across here, we'd find our 40, we'd use our graph, we'd go up and across. So we could say roughly 15 British pounds. How many Australian dollars is 10 British pounds? So this time we need to go to our 10 over here. We go across to our graph and down. So we could say roughly 25. Now, when you draw your lines, it should be beautiful and straight. The laptop's not letting me do that today. Now, if we wanted to find the gradient and vertical intercept of the conversion graph, we want to use the point that we were given. So we're going to use the point up here. So 100 Australian dollars, 40 British pounds. Our intercept is going to be 0. And our gradient, so because we're going to use our 0, 0 and the point we were initially given to find our gradient. So on the run, we've gone across 100 to get to Australia, and on our rise, we've gone up 40. So that's going to give us 2 over 5 as our gradient. British pounds equals 2/5 of the Australian dollar. Talking about direct linear variation or direct proportion. So this is when one variable depends directly on another variable. So as one increases or decreases at the same rate as the other quantity increases or decreases. So a person's wage, they depend on the number of hours worked. The more you work, the bigger your wage. So when we're talking about direct variation problems, there is a constant K. That's the rate at which the quantity varies. So if we were talking about our wages again, the hourly rate would be our constant of variation, and that's what we would use to determine our weekly pay. So if we want to solve direct variation problems, we need to write an equation relating the two variables and use that information to calculate the value of K. So this is very similar to our y equals mx plus c. The only difference is here we don't have that plus c. So how we would solve it is we'd write our equation as y equals kx. We would put in the values that we know, make k the subject of the formula. That will solve for k, and then we can substitute that into our formula. So a couple of examples. The cost of a photocopier varies directly with its speed. A photocopy with a speed of 50 pages per minute costs $700. So we want to find the constant of variation. So we're going to be looking at C equals KS. So our copier was $700, and that equals 50K. So K is going to equal 700 divided by 50, which equals 14. So write the equation C equals 14S. How much does a photocopy with speed of 60 pages cost? That's going to be C equals 14 times 60, which equals $840. Our second example here, our table shows the cost of postage as a fraction of the weight of the parcel. So to find the constant of variation K, we have C equals KW. We can pick any point, so I'm going to just pick this point here. So our cost is $120. We've got K times 1. So our K is just going to equal $1.20. So writing the equation, we're going to have C equals 1.2W. So if we wanted to find out how much a parcel weighing 12 kilograms would cost, we'd have C equals 1.2 times 12, which equals $14.40.